Welcome back, scholars, for lesson 2 in our unit 1 exploration. This lesson is going to be on estimation techniques and graph interpretation. Once again, we have a vocabulary on the right hand side. Our vocabulary words for this lesson include estimation, bar graph, pie chart, and line graph. Please make sure that you look up those words however you see fit and define them. Our learning objective is we are learning to identify different uses for estimation so I can effectively implement various estimation techniques. I'll know I've got it when I can estimate the solutions to various real-world phenomena. Let's begin. We call the process of finding an approximate answer to a math problem, or any problem for that matter, estimation. Go figure. There are multiple ways that we can estimate, but we are going to focus on 5. Okay, the ability to round, the ability to estimate costs. Okay, both of those kind of go hand in hand. The ability to work with bar graphs, pie charts, and line graphs. And I can't um, overstate the importance of being able to look at graphical representations of data and interpret them um, to a high level of integrity. Case in point, the previous presidential election featured a lot of data that was thrown loosely around in an effort to paint a picture that may not have necessarily been the most true. It requires you to apply your mathematical estimation techniques to properly see that data, interpret that data, and process that data to properly inform your decision. Okay. In the case of us rounding numbers, and this might get a little difficult to write, so don't worry about writing on the whiteboard because it'll be difficult, unless you want to, because like I said in the last activity, this is becoming your digital Juba notebook. So if you want it to be as thorough as possible, you can write out what we'll include on our whiteboard, but if you just want to go back and watch the video after the fact, you totally can do that too. So first and foremost, we want to locate the place value digit of the number that is being rounded. Do that first. Okay. If you've forgotten the place values, fear not. That's the kind of the point of this video. I guess yeah, I'll use the pen here on Desmos. So first and foremost, this location here is our ones location. Okay. As we proceed in the left direction for numbers, we are applying this times 10 style of mathematics. Our society, our world operates in a base 10 system. So if this would be the ones, if we did 1 times 10, we would wind up at the tens digit, and then 10 times 10 becomes the hundreds, and then 100 times 10 becomes the thousands. Can I move this? Oh, I can move this. Look at that. Right, and then so on and so forth. So then just to reiterate, right, every time we are moving left one place value, we are multiplying by 10. So if we are proceeding in the opposite direction from our ones location, rather than multiply by 10, we divide by 10. Hence why we would call where this 2 is in its place value, we would call it the tenths, right? The 1 divided by 10, 1/10. And if we take 1/10 and divide it by 10, that becomes 1/100th. ran out a little bit of room. So as you can see, this can become a little tedious, especially if you're doing this with your mouse, right? But 1/100th divided by 10 would become 1/1000th, and 1/1000th divided by 10 would be 1/10,000th, so on and so forth, right? When we're rounding, if we were to identify the digit to the right of the place value is 0 through 4, don't change the place value digit. So don't change the place value digit. Okay, right now we're kind of speaking abstractly because we don't have an example to kind of work off of. But if we were to look here, we use a different color. Let's say we use green, right? Let's say I wanted to round this number to the nearest 100. Okay, I would identify the 100 place value. I would look to the right. It's a 6. And as we can see here, if the digit to the right of the place value is 5 through 9, I don't know why there's this gap, we would want to increase the place value digit by 1. Okay, so I would take 85730, I would leave that, okay, and then this 2 is now going to become a 3, and the 61 will now become a 00, right, because that would be 300 to the nearest 100. Okay. Words of wisdom: when you round whole numbers, replace all digits to the right of the digit being rounded with 0. Whole numbers are all those values greater than 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When we're rounding decimal numbers or fractional values, you would want to drop all digits to the left. Oh, sorry, brain fart. Right, drop all digits to the right of the digit that is being rounded. So if we wanted to round this to the nearest 100th, right, so let's say we want to round it to this place value, we would look to the right. It is a 5, so we're going to increase this 3 based on our rule here, and then those values, those place values, will disappear. So basically, we turn in anything to the right, 0. Okay. So in this instance, you have a few numerical values to work with. Okay, they put the place value that they would like in parentheses, and there's also a little application problem for you to estimate the total cost of 6 refrigerators. Okay, remember, we don't want to estimate the cost too liberally. Okay, each refrigerator is supposed to cost $579.99, so we wouldn't want to say that they're worth $1,000 because that's a bit of a stretch. I mean, while I like to make sure that I have a decent amount of coin just in case something goes awry, it's a little too much. Okay. You're considering a new cell phone plan where you have to pay $179 upfront for the latest phone, but the monthly charge of $39.99 includes unlimited minutes and messaging. Feel like a T-Mobile ad. Estimate the cost of the phone for 1 year if there are no additional charges. Okay, so there are certain things to consider with the phone plan, right? We have the registration fee here, $179. We have a monthly charge of $39.99. Okay, that is key. Okay, that $39.99 is most likely not going to be a one-time fee. Okay, so please make sure that you demonstrate your work in this box, making certain to use our math type button and all the function keystrokes. Words of wisdom: there is no correct answer when choosing what to estimate to. Just evaluate the situation and use good old-fashioned common sense. Now, in this instance, if you want to be specific, you can, but we're estimating the cost for the phone, okay? Because we're trying to do some quick math, make sure that it fits into our budget, etc., etc. Let me clear this. There we go. In this instance, we have a bar graph which shows the percentage of electricity generated by nuclear energy in 5 countries. Find the approximate percentage of electricity generated by nuclear energy in France. Okay, so that's part 1. and estimate the difference between the highest and lowest percentages shown. Okay. We have all of our countries along our x-axis and the percentage of use along the y-axis. We also have some vocab words that we should look to define. Okay. A bar graph is used to compare amounts or percentages used in either vertical or horizontal bars of various lengths. The lengths correspond to the amounts or percentages, with longer bars representing larger amounts. Yes, maybe a little bit overkill, a bit obvious. However, we don't want to assume that all of this knowledge is firsthand. So, like I had mentioned in the beginning of this video, being able to interpret data is one of the most overlooked skills, and currently, I think one of the leading skills required in the new digital age that we operate in. So in this instance, we have a pie chart, which is constructed by drawing a circle and subdividing it into parts called sectors according to the size of the percentage of each portion in relation to the whole. Please make sure you go ahead and answer this question, and we will pick up with the enhancement opportunities tomorrow together in class.